Good afternoon, everybody. Good afternoon, all the participants. Thank you for being here and listening to what we have done. So our deployment started just with the SPaT challenge. We didn't have a statewide program yet. We just wanted to learn about the CV technology out there, get our feet wet, and learn in the process. So we started with selecting a corridor that had less impact in terms of hardware and software upgrade. Town of Cary, where we selected the corridor to be to deploy the technology, had a central software system provided by Econolite Syntrax. All the intersections were connected to the traffic management center through a Ethernet fiber optic network. The software that we were running at the time was ASC3, again, Econolite product. Also, this corridor, it parallels the Triangle Expressway, which is designated proving ground for connected vehicle technology. So that was another reason why we selected this particular corridor. 20 intersections, 16 intersections along NC55, and 4 intersections off of NC55 on I-House Road. This is the overview of every intersection in this project. This is the I-House Road, where we have 4 intersections equipped with CV technology. The next 3 slides here basically list every intersection that is in this particular project equipped with these RC radios. I'm not going to go over each one of those, but those are listed for your information. So basically, again, we wanted to have the least impact in terms of design work and in terms of hardware. So we already have Econolite equipment. So we wanted to go ahead and select a vendor or a contractor that was familiar with what the intersection equipment were and what needed to be done. So we awarded the project as a sole source to Econolite in July 2017. Initially, part of our RFQ was to use Savari RSUS and OBUs for this project. And we were anticipating this project to be completed in 19 weeks. And it was a turnkey project. Since we were just beginning to learn about connected vehicle technology, we wanted to minimize the load on our staff and maximize that on the contractor, so they would teach us, what we needed to do and learn from the process. The payment type was not a lump sum; it was itemized. Basically, the itemization had to be the RSUs, the OBUs, integration, testing, training, and installation. So our project total cost was about $506,000. That translated to $25,000 plus per site, per intersection. So the existing infrastructure, as I said, was NEMA TS2 cabinets with 2070E controllers and Econolite ASC3 software. The system was interconnected through a Ethernet fiber optic network, and the central software at the traffic management center was Syntrax 2.1, I believe, at this point. What we needed to upgrade was to upgrade the 2070E controllers with the 2070C or Linux. So we had to redesign the intersections with the ASC3 Linux platform, ready for connected vehicle and high-resolution data. The additional equipment that we had to install, obviously, were RSUs and the Econolite connected vehicle CoProcessor, POE injector, surge suppressor, cabling, equipment mounting hardware, and also we had scoped 5 OBUs for validation and verification of the system. So prior to going live and install equipment in the intersections, we wanted to set up a test site to make sure the equipment that we have selected, the software and everything works properly. So we set up a test location within our DOT facility. We installed the equipment, created the map messages, the SPaT messages, and verified that everything works. So basically we proved the concept, and after that we went ahead and installed all the RSUs in the 20 intersections that we had identified. Unfortunately, we ran into some problems with the Savari RSUs. They missed delivery times. There was problem with the units themselves. Then the unit had to be sent back for firmware upgrade. Technical support was not really available. I think their engineering department was in India, and the sales department was in here in North America. So whenever we needed to get technical support, that presented a challenge because of the time zone and the difference in the night and day. So there was a lot of issues with getting technical support. So based on those challenges, we decided to reboot and restart the process, and considered to go with an evaluation process where we invited multiple vendors to install their equipment and gave us a chance to evaluate the performance, their technical support, and so on. So we could select equipment that are more user-friendly, and the technical support was more readily available. So we issued invitation to 6 different vendors, Siemens, CAPS, TrafficCast, Lear, Applied Information, and Savari. Again, we wanted to give another chance to Savari to see if being in the competition will make any difference in terms of providing technical support. In the evaluation process, we invited multiple agencies to take part. Obviously, NCDOT was a main player. Town of Cary, where they own the signals. Econolite, our contractors, and City of Concord, North Carolina, also participated because they also wanted to participate in SPaT challenge deployment. Some of the evaluation criteria that we wanted to look at was obviously functionality, available applications, interoperability, documentation, ease of installation, configuration, over-the-air firmware updates, map development tools, support, and the unit itself, the form factor, and how easy or hard it would be to install. So based on those evaluation criteria, we ranked the different units as CAPS came number 1, Siemens number 2, Lear 3, TrafficCast 4, Applied Information 5, and Savari 6. Again, we didn't get a lot of support from Savari, so they ranked really low. Applied Information was not a DSRC technology, they're 4G technology. So obviously we did not consider them for this project. And we went with number 1 and 3, and we again did not select Siemens, although they ranked number 2. That was because they did not offer at the time an OBU for validation and verification purposes. So the new RSUs from CAPS and Lear were ordered in May of 2018, expecting delivery in July late June, early July. We completed the installation in late July. We completed training in August, and the system has been operational since July of 2017. So here is the some of the images that we have from the installation. So we received two different OBUs, one from Lear and one from E-Trans Dunlaw, which is partnered with CAPS. And also part of this OBU system was an HMI, basically a Samsung tablet equipped with the applications. Here are some of the images from our verification and testing. As you can see, we have the red light violation warning application implemented. We have the flashing yellow arrow demonstration here. And obviously you can see the red light and the time that is left in each phase as shown here, 22 seconds, for example, here, 16 seconds, and the flashing yellow, 2 seconds left. And so over here, you can see that the red light violation warning is a predictive, although the phase right now is green, but based on the speed and the trajectory, the application, predicts that if we go to the speed and the time remain, that we might be violating the red. This is the Dunlaw OBU, and with E-Tran applications, again, some of the applications that we have implemented is work zone warning, red light violation, school zone, it's not shown here, curb speed warning, and speed limit warning. I don't have images for those, but those are some of the applications that we have implemented. The lessons that we learned from this deployment is obviously to start the FCC application early in the process. It takes a long time, and it takes a lot of effort to procure the different licenses, the geographic and the site licenses. Again, since this was a turnkey project, we did not write a whole lot of a specification. We didn't have a lot of functional requirements in our RFQ, so the next phase of our projects would be to make sure that we have written detailed functional requirements and start with multiple products and not just select one, just because, the products out there, and to our experience, they're not very mature, so they still need growing and testing and evaluation, requiring comprehensive testing and training. Again, if the purpose and the intention is to become expert in the field, that we would need to get a lot of training from the contractor, so we can maintain and operate the system efficiently. Documentation, again, is a must, and being hands-on is also something that we wanted to make sure in the future be a part of that. We required a coprocessor as part of this project. So basically, the coprocessor was to do the translation between the NTCIP objects in J2735, but through the project, we learned that the coprocessor was not needed because the translation actually happened inside the RSUs. Lead time for equipment is long. I think in our case was 8 to 12 weeks. Some of the problems that we ran into as the system were up and running, we had a problem and we needed to replace one, and it took us a long time to get a replacement part. So that's something that we learned, that as part of the future projects that we specify or include additional spare parts in order to make sure the system continues to operate. I think another thing we learned that there was some equipment were built based on a previous 2009 specification and some were based on 2016. So we wanted to make sure that our project requirements in the future will be consistent on the standard that we will require. In map creation, that was another big challenge. Although our contractor created the map using Google Earth Pro and then a translation from the KML files to XML file in order to upload those files to the RSU. So that was a big challenge. And an easier way to do this and an easier tool to do this obviously would be a plus. So again, to summarize, the challenges is to expect delays. That's part of the process based on, again, the time it takes to get the licenses for the locations, equipment lead time, and there obviously could be weather elements involved. Other challenges that we had with the technical support, so that's another thing to expect during this process. And applications and the hardware, again, is in our experience needs maturity. So to keep expectations not very high, I think that's part of our learning process here and what we learned. When we installed the radios, we installed the existing signal poles were metal, and we did not have an electrical insulation between the RSU risers and the signal pole. During the hurricane here, I think we had a loose power cable that touched the signal pole and basically fried all of our equipment on that particular installation. So obviously for us to go to move on future projects is to consider electrical isolation between RSU risers and the signal poles if they are of metal type. Again, like we started this project with just meeting the SPaT challenge, but we are in the process of developing a statewide policy for deployment of connected vehicle technology in the future. We will be expanding this particular corridor to another 18 intersections to have these RC radios from vendors that are not currently installed. So basically, we have CAPS and Lear, and we want to go down the list that I presented earlier from the other vendors that we ranked and evaluated, so we can get a feel for the other products and applications. As part of our process and the new signal system projects that we will be working on, we are programming into those projects to identify additional intersections and corridors that make sense for CV technology to be deployed and include that as part of the projects. And also, even if we are not including CV technology in the new projects, we wanted to make sure that the signal equipment that are being upgraded or installed are ready for connected vehicle technology. And in our case, we have a statewide license for Econolite ASC3 software. We have a version that is OS 9 based and a version that's Linux based. And the Linux based is the one ready for the CV technology. So we wanted to make sure that our new signal projects considers the software and the hardware that is ready for CV deployment in the future, even if we are not deploying it within that project. With that, that's all we have done currently in North Carolina. As I said, we are in the process of developing a policy for CV technology deployment statewide. We continue to learn, and we have learned a lot from this process, this challenge, and we are hoping to further our knowledge in the area and develop the in-house expertise in the staff to be able to operate, maintain, and deploy additional technology. In addition to this DSRC, we also have 7 intersections that were not part of the SPaT challenge, but they were equipped with 4G technology to also gain some insight and some knowledge into how the 4G technology compares to the DSRC in terms of SPaT message broadcasting. With that, I thank you for your time, and be happy to answer any questions that I may be able to.